Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Judith is a professor in the Department of Computer Science at the University of Pretoria, South Africa. Her research interests are programming languages and distributed systems. With Nigel Horspool, she co-edited the IEEE Proceeding Software special issue on Rotor research that came out in 2003. And I'd like to acknowledge that Judith has provided a tremendous amount of support and energy to the Rotor community since 2002. Catherine Berg is a master's student at the University of Pretoria. She's been a research assistant at the university since 2001 and is currently researching in the field of variability management and software product line engineering.
Okay, good afternoon. As you already heard, I have nothing really to do with our Rotor project. I do research in a different area. So I would like to say ahead of time, if you do have any questions, please feel free to contact Professor Judith Bishop via email, and she'll gladly answer any questions that you do have. Okay. The project I will present to you is called RoSCtor, which stands for Software Construction within Rotor. As background, software construction recognizes the importance of choosing the right programming techniques to achieve acceptable levels of, for example, performance, maintainability, and reusability in software development. Someone involved in software construction would be an expert on alternative constructs provided by programming languages, libraries, and software systems, as well as techniques which can be employed to render a huge system understandable. The objectives of the RoSCtor system project were to raise the profile of Rotor as a product by tackling the documentation of some of Rotor's components. Some of the outputs would include the documentation, the assessment of the inside constructs of the system, some recommendations for new ports of Rotor, and also courseware. Project members, as already mentioned, Professor Judith Bishop was the leader. She was assisted by some postgraduate students, John Miller and Basil Worrell. They are part of the Pullela Research Group, which is headed by Professor Bishop. Then there were still a few fourth-year students from the University of Pretoria and University of Karlsruhe who also assisted with some of the project tasks. The main way of trying to get the project done was to get groups of students to study and report on the construction of individual components of Rotor, develop the documentation and make it available online. When trying to document and understand a large system, they realized it would be a considerable challenge, so they decided to ease the task of tackling Rotor. Students would be exposed to other systems that were better known, such as the View system, which was written under another Rotor grant by Professor Bishop and Professor Nigel Horspool at the University of Victoria. Now, Views is a vendor-independent, extensible windowing system, which basically lets you define user interfaces using XML. A large part of the project was to present two new software construction courses at the University of Pretoria in South Africa, as well as at the University of Karlsruhe in Germany. In Pretoria, there was a software construction course presented to fourth-year computer scientists and engineers from February to May and from August to November in 2004. And at the University of Karlsruhe, a software construction in the .NET environment course was presented to third and fourth year computer scientists from May to July in 2004. Some of the course outline is listed there. For example, teaching students about object representation and behavior, multilingual programming, the shared source CLI initiative in Rotor, issues of security, documenting large systems. These are just some of the things taught to the students. Here are some sample assignments that students had to do throughout the course. They had to create sample applications using views on Rotor. They had to document views and parts of Rotor. They had to refactor existing systems using aspect orientation and implement generics in sample applications. Here are some comments of students of what they've learned during the course. Some have learned the importance of documenting their design choices when developing software. Others have gained knowledge in the .NET platform and its libraries. Some were introduced to a whole new programming paradigm, and others have been introduced to concepts such as generics also for the first time. While looking at large systems and trying to document them, an interest in aspect orientation emerged. Students wrote programs using aspect systems for C#. They investigated several C# AOP systems. However, many did not work, or they didn't manage to get it working. They found that the best system was EOS from the University of Virginia. EOS is a aspect-oriented extension for C#. Some more students comment of what they thought of the course. They enjoyed hearing about new technologies. They thought it was quite fun to have guest lecturers giving some of the classes. They thought it was a very practical course. It was interesting to them to learn about aspects and generics. And they also liked learning about .NET in an academic setting with a critical view on the system and design choices. Throughout the project, they collaborated with some other people, for example, Walter Tiki from the University of Karlsruhe, who initiated the course from the Karlsruhe University side. It was the first .NET course presented at that university, and it was also the first new non-Java course presented there for quite a while. Damien Watkins from Microsoft Research in Cambridge also gave some guest lectures. Bertrand Meyer from ETH in Zurich spoke on his Eiffel project on .NET. And Nigel Horspool from the University of Victoria in Canada, who wrote also the view system, and he participated on a consultative basis. Some of the project outcomes were that 3 software construction courses were successfully presented at 2 universities. About 80 students used and examined Rotor. The view system was partially documented using some of the documentation tools available. And considerable experience was gained in Rotor. However, there was less of the documentation done than anticipated. Some outcomes in terms of software was a methodology for retargeting APIs was developed. A student project was to port views using Qt to Linux. And a new system called Mirrors, which applied reflection to create a dynamic version of the view system on .NET 2. Now, the Mirrors system was developed by a third-year student, David John Miller, also a research assistant at the University of Pretoria. He just last week found out that he won second prize at the Microsoft South Africa Developer Competition on .NET 2. Some outcomes in terms of papers. There were 2 papers submitted and accepted at conferences and 1 journal paper. They are all sort of based on the work that has been done on Rotor or in that area. As conclusion, the RoSCtor project stirred up quite a bit of interest in the use of Rotor and .NET, especially amongst the students that participated in the courses. Then there were more software and paper outcomes than was originally anticipated. However, not as much of the documentation of Rotor was done as was aimed for. In future, the retargeting projects are continuing, and the courses are being packaged for reuse at a later stage. Thank you. Like I said, any questions, please ask Professor Bishop. You can get her contact details from me, but they are also available online. So, thank you. Oh, and there's a link to the project page for more information. Okay. A little bit early. We'll have a long tea break.
Yeah.
Okay.
Well, let's thank our speakers for this first session of the afternoon.